0, and then you get to another 50%, 0, 30%, 0, 10%, 0, 5%, that adds up to 100%. So you get these areas of 0% that a particle never hit at all, and that's 100% predictable. And then you get the probabilities between 5% to 50%. Now I might be a little off on my math, but that's only because I'm talking to you in terms that you can understand. Because you can have any number of lines going across this sensor. So I'm about to explain the particle wave experiment in a way you can actually understand, and entanglement, how that works, and how it gets to particle development, and that a particle is not actually a wave. You might be a little confused by that. The particle doesn't travel as a wave. But there's something underlying that makes it travel on waves, so it appears as it travels as a wave. So let me explain this. So the fundamental, and we're going to go further than this. We're not taking it at basic quantum mechanics. We're going to go way further, all the way up into string theory. I believe in M theory. I think that's a thing. It's becoming a thing. But I'm also going to have to start with string theory. So let's continue and understand that physics isn't just math. That was already debated, because Einstein had his ideas, and Einstein used a mathematician to help him with his ideas. So physics is not just math, it's theory. It's theory, it's non-theory, it's what you can see, it's objective, it's describing the universe in a natural way. So you need to understand that it's not just math, but it uses math to help it get into predictabilities, because math is a great thing to find into predictabilities. I think for me personally, understanding the universe is more important than understanding exactly the math of the universe. However, I do respect the math of the universe that we've invented because of repeatable success. This is why I chose physics and not to be a mathematician, so forgive me if I'm off on some of my numbers. If I'm off on some of my numbers, I can go back and we can go double check that and we can go over it again. This was already debated, like I said, since the early 1920s, 1930s. That's why Einstein got the credit, not the mathematician, not the other guy who was doing the math with him, because Einstein's the one who first came up with the theory. He wasn't completely complete with his theory, but he came up with the theory, and eventually he came up with some completeness of his theory. So, and concepts can be infinite. Why? Because I didn't have to go through all the math Einstein had to do and not reinvent the wheel. I can understand where Einstein got to his result and look over it and keep that in memory instead of using up all my cognitive function to produce that. That's why we keep progressing in science, because now our older science is put into our memory bank. Because it takes a lot of effort to come up with a new theory. Alright, so let's explain how this works. I'm going to start from the really, really bottom hypothesis of how particles are made, and then I'm going to get to the forces involved, all four of them that we know of. There might be even a fifth one. But we haven't discovered the fifth one outside of gravity yet. And I'm going to get to pretty much all of the universe, but I'm calling it energetic wave frequencies because the theory of everything's already been taken. And I think it's kind of arrogant to say the theory of everything, you know, right? But it's been taken twice. One on the biological, neurological side, and the other on the scientific side. Which I love biology, and I plan to also get some education in that too. So let's go into energetic wave frequencies and why they are important. not just why they are important, I explained why they are important earlier. I might recap on that later. So particles are developed. Remember, particles are strings, right? So particles are developed by these energetic wave frequencies. So the hypothesis is that energetic wave frequencies, and that's not a fact, that's just me asserting an assumption which I'm going to prove with facts. Okay, so energetic wave frequencies, when they are when they have their waves, they're at the peaks of those waves. The peak, which is part of the wave at the top, what you get is the particle. This is why the particle seems like a string, and at the peak of all waves, even including in water, not just like magnetic circumference waves, but I'm talking about the peaks of all waves, they usually have a little bit of a ripple in them. And so that's why they're strings. And those peaks dim off into the fineness of these energetic waves. They also dim off the other way as well. And so they travel on the peaks of those waves, or in the crests of those waves. And these waves aren't two-dimensional, these are three-dimensional, can be in any wave, shape or form, but they're mainly, just think about water waves for now, because we can get into abstract thinking later. So when the particle, let's think of it in two-dimensional before we get to three-dimensional, we'll get into three-dimensional again after I explain this, travels on the peaks of the waves, and I'm also going to explain how these waves also help develop the forces of the particle. It travels on the peaks of these waves, it gets to the two double slits, and the waves that surround it, that build it up, hit these double slits before the particle, and those waves create an interference pattern. And the particle is now feeling the interference pattern in stronger pull or push to the left or the right. And so it gets into the stronger right or the stronger left of these two slits. And then the particle travels along the left or the right, however now it's like an interference pattern. And so when the particle gets to the sensor, after it passes the two double slits, it is in a capacity where it's at the peaks of the interference pattern, or the crevices of the interference pattern. It could be either or, but it's never both. And so when it gets into the peaks of this interference pattern, it hits a spot on the board. And note on the board that there's no place where it's 1% in between two full figures. It's always 0% in between two full figures. So this is a really great explanation for this. Now when we look at the particle after it goes through the double slits, what we effectively done was we sent the photon to the particle. That photon also has the same types of energetic frequencies, which disrupts the energetic frequencies of the other way, collapsing the energetic frequencies, basically also collapsing the probability waves, which cause it to go into the way we see without the double slits, because then the particle is recalibrated on regular waves, in which way it seems as though it's traveling as a regular particle, which it is, but we got to stop thinking of particles as spheres and particles as traveling on peaks of waves, but not necessarily waves. So these particles are made up of these waves, and the basic peaks of them, when we describe the particle, we're describing strong force, really strong force at the peaks of these waves. Understand that this is not literally water. This is a almost zero energetic frequency that produces a 1. Let's just keep it in a binary manner. It produces a 1, a particle. And when that particle is produced, it has patterns of waves inside the particle that creates strong force. It has the dips of the wave, because the energy that took to produce the wave, the peak of the wave, has a dip of circumference around the particle. This is where we get into the weak force. So there is a certain distance from the particle that is weak force, because the dips of the wave are thinner. The waves are thinner around the particle, and the closer you get to it, it gets thicker. And the further you get away from the waves, they normalize into the regular energetic frequency waves. So this is why other particles do not collide, because it takes a certain amount of energy, energetic frequency waves, to develop the particle. So now let's get into another idea. The patterns of strong force and weak force, the waves, the condensed waves and the weak force waves, have also different types of patterns. And what that develops is now we have positive and negative forces. Now we have magnetism. So as the particle is spinning left or right, we can only, I'm just doing this as a general hypothesis. It could be different. It could be the way the waves inside the particle are spinning. The particle itself does not have to be spinning left or right, but the waves inside the particle are spinning in a certain direction, where the other waves inside another particle are spinning the opposite direction to create magnetic push and pull. And so with opposite directions, you get more pull. And I can give a small example, though it's not going to be complete. What happens when you take these two cans, though yeah, they're not nearly as small as particles, is that when they spin in opposite directions, they're just fine. But if I took these cans, let's say they were gears, and I spun them in the same direction, which, let me think, yeah, they have friction. And the energetic frequency waves work almost necessarily the same way, because there's more dip with the friction than there is with the non-friction, because particles generally hug the opposites. And so we created magnetism with strong and weak forces, which the energetic frequency waves explain. Now let's get into entanglement with partial of the force of attraction, but I want to get into entanglement first, and then I'll come back to the force of attraction, then I'll come to gravity eventually. So when we get into the force of attraction, oh my bad, I was going to go to entanglement. So when we get to entanglement, it's when two particles share certain frequencies that are very similar on their energetic frequency waves. If two particles collided or came close enough to mess with their energetic frequency waves they share with each other, then the energetic frequencies that they have come close enough in contact to be entangled. Or for some reason over long distances may entangle itself with a particle that's extremely far away, but this is also a rarity. So now I'm going to get into, and this is why they're connected. When one spins one way, the other spins the other way. Notice that relates to exactly what I was saying with energetic frequency spins causing magnetism to exist. So now I want to get into the force of attraction. So the force of attraction is when the energetic frequency waves after the dip is stronger, not stronger than strong force, but stronger, slightly stronger than going up towards the particle. This occurs for every single particle, so every single particle has a certain force of attraction, but they never combine because of the weak force, obviously. That's basically the weak force explained in energetic frequency wave theory, which is my own personal theory. Which it also helps explain dark matter. Why does some dark energy, why does some particles light up at random times? It may help with explaining radiation and stuff like that. because we all know that every single particle in the known universe has radiation, right? Because it radiates photons, light, and stuff like that, including the photon itself. Because a photon is basically radiation. I could be wrong. Correct me if I'm wrong. Now I want to get into gravity. So since the energetic frequency waves make up the particle, when the particle finally is aligned into making up an atom, which is a system of atoms that have strong weak forces and magnetism. Now when you have a cluster of magnetically pulled, attracted atoms with the force of attraction increases. Also, the positivity of the force of attraction increases, and the positivity of the magnetism is increased. So essentially, this can only occur in a mostly positive universe or a mostly negative universe, because the force of magnetism aids in the force of attraction, because all atoms are mostly positive, as we know from the electron being extremely small and the proton being extremely big in its positive notions, and there's always an equal amount. However, there's more positive in the proton than there is in the electron. That's what we would expect, and so they correlate with both of these. And so the addition of both the force of attraction and the force of magnetism is the whole addition of gravity. It's a sum of all the forces, essentially, but not strong and weak force. And so now we're getting into mass not producing gravity, but as a result of the dips in between being a pull force only, because circumference is the opposite of that. Not circumference. Centrifugal force is the opposite of that, right? It's the counter force. There is no push in gravity. There's only pull. Any illusion that you might have had that there was a push in gravity is gone, because there's only pull in gravity. The reason why the planets are separated from the sun is because of the speed they're going around the sun. So I hope you don't have that confused with orbit, because the Earth is not ever in a stopped position. It's always moving. Likewise with other planets. Okay, there's always motion. And if you look at two stars and you're like, why aren't these two stars orbiting each other? Think about the thing that they're orbiting. They're also orbiting the black hole in the center of our universe, and as Andromeda and our Milky Way galaxy are coming together, understand that there's a small orbit happening there too, extremely small. This also helps explain somewhat of light, maybe, but I'll get into that really awesome theory later. Let me take a break for a minute. So my answer to the question, I have two answers to two questions, first of all, from two renowned physicists. I have an answer to the Einstein question of why did light bend twice as much, and I have an answer to Michio Kaku's question of why isn't the universe, because in quantum mechanics we discovered that the universe should be equally antimatter and equally matter, and I have an answer to both these questions. I actually want to answer the antimatter question first, because that's the coolest and I like the better challenges. So I don't have a magical theory that makes it happen. I have a theory that builds particles, which also helps and possibly builds atoms. But understand that when you get into atoms, like I said before, that you must have a more positive universe. So we're only on the particle level. So we're on the particle level in the first universe. We never reached the atomic level. And so what happens is a positive particle and a negative particle that is the same components of that particle, these are now antimatter. And their attraction is stronger than the weak force that can hold them back because they're equally the same size. There might actually be, I'm not 100% sure. I actually just want to stay with my first hypothesis. I don't want to make this more complicated than it has to be, but if I have to make it complicated, I'll do that later. So what you have is two particles. Actually, you have billions upon billions of particles being developed by the energetic frequency waves. You have to understand that these waves aren't flat, because if they were ever flat, how would they ripple? Understand that. How would they ripple? Because we honestly think of ripples in forms of matter as a cause and effect. But we can't think of that in these forms of ripples. Because these forms of ripples are not water, as I said before. They just ripple. So, at the start of the prerequisite universe, there was never a start. It was always as it's always been. Because energetic frequency waves are eternal, just as energy is eternal, and just as it gets into momentum and stuff like that, but I'll get into the kinetic energy and the potential energy later, because those react with forces. Understand that kinetic energy and potential energy are also reacting with forces, which I just explained that forces are the way that energetic frequency waves act around a piece of matter. So in the prerequisite universe, there was a part. We have to start with this position. There was a particle that was positive, and there was one that was negative, and they collapsed into each other, exploding. Now, obviously, in the particle accelerator, we understand that creates a small black hole, but there is a lot of debris. I say that these are really big particles compared to our universe, but compared to the one that I'm talking about, they're probably the same size if you were in relative size to that universe. And on the more positive end of that universe, what we have is smaller energetic frequency waves. Likewise, on the more negative side of that universe, what we have is smaller energetic frequency waves of the same size. And then we get to a lesser positive, but still more positive part of the universe, and I think that's where we're at of this explosion. The reason why we don't see the opposite universe that's supposed to be negative of our own, the parallel universe, mathematically proven, and it seems obvious in quantum mechanics because of cosmological constants, but that might not be a thing, or complex numbers, stuff like that. But that's also could be the thing. And so the case we have is the light that's going towards our own universe is going the speed of light within its own universe, which is the same speed limit as our own universe's speed of light. The light outside our own universe into the prerequisite universe is a different speed, obviously because of the relative size and of the energetic frequency waves. So the reason why light travels at a certain speed is because of a number of things, but I'll say let's just start with energetic frequency waves and forces. Okay, so that's why light has a max speed. Because why would light have a max speed unless there was another explanation? And so I think that the Big Bang was actually caused by two particles, one positive and one negative antimatter particles exploding, and we're on the more positive side. We'll never ever see the negative side of the universe. We are first of all traveling the speed of light, and second of all, they're traveling their speed of light. And within those speeds of lights are relative to their own material objects, so they can only go the speed of light away from a material object. So we are in a weird situation where you get galaxies that seem like they're traveling faster than the speed of light, and are arguably, but they're going through void space with no gases, no forces, nothing like that. So it's actually possible that the energetic frequency waves between galaxies and the gravity is just not there, and that the held back of the speed of light is due to gravity. Like I said before, though, the second reason why we can't see this light is because the black hole in the center of our universe pretty much that is containing all the light from the other side, and we're also traveling away from it at a certain speed, so the light will never reach us even in void space, because I assume that light still has a max speed. Once you get a bigger energetic frequency wave, even though it's traveling faster, it still has a max speed. Okay, so even though it still has a max speed, understand our galaxies are not relative to each other. So they can travel as fast as they want because they're not relative to each other. So they're necessarily, arguably, to relativity, not actually traveling faster than the speed of light. But if we try to make all the galaxies relative to each other, it wouldn't work. That's why relativity falls apart outside the galaxy, or the galaxies that are connected to each other, which ours being Andromeda. Get into the really cool sci-fi stuff because I don't want to bore you. I think I had another question I was going... Oh, I already answered relativity. I did it by answering the first question. No, I didn't. So, the reason why light, I think, arced around the sun at twice as much as Einstein predicted is because there's a Goldilocks zone. And I know I'm using the wrong term. I'm going to try and use a better... We'll just say a golden zone. So at a certain point, gravity is further than magnetism is. But magnetism is to a certain distance too. It has I don't want to say a max distance, because we know that forces get infinitely smaller and can go infinitely outward. Just there's a point of relevance where it doesn't really affect the particle as much, and it goes into a bigger energetic frequency waves that aren't relative to the smaller ones. So what I'm saying is, as we see light arc twice as much, we're seeing the zone that we measured it at, because have we measured it at different zones where it arced. When we see the measurement at where we see the arc, we're measuring both magnetism and gravity in that zone, not just gravity. And to a certain point of that magnetism and gravity, the equations of gravity being, and I might be wrong, but I believe it's cubed squared the power of magnetism and cubed the power of the strength of it. So the strength of this mass, we have it cubed in distance in gravity. It's really difficult to explain, but I'm just giving you some arbitrary, I'm just giving you not something that's too hard of an abstract number, and it might not be right, but it's just an explanation. And then we have to the point where we're at the furthest distance that magnetism has on a particle, while we're in the pressure that gravity, I'm using pressure, but I know it's not pressure, that gravity has on that same particle. So we have to account for magnetism and gravity in the arc, because it may not arc the same way in different locations, and it may have to be in different distances for us to measure this, and we only measured this 2 times. So we really should measure it way more before we assume that there is something like loop quantum gravity, which asserts there's dark matter, even though we found no evidence of dark matter. In fact, we found the opposite. I'm not saying that dark matter doesn't exist. What I'm saying is there's not 74% in the known galaxy, in the known universe. That there's a sum of these forces that work together at certain points. And we also have to think about chain gravity. How far does my gravity of my sun affect the closest star 4 light years away. How far does it affect it? It turns out that the effective gravity of the sun goes out 50 light years. And so this chain gravity idea actually works with the spirals of the galaxy, and actually works with the fact that the galaxy is somewhat like a disk. This also works with the fact that our solar system is like a disk. Because if it works with the fact that our solar system is like a disk, because the orbits are arbitrarily like a disk, because if it wasn't arbitrarily like a disk, certain things wouldn't be affected in certain ways where they didn't have that accumulation of gravity that chains out everywhere. And so we have Pluto. Here's our dwarf planet that we have, that when it travels around the sun, it's actually going outward. And the same thing with Neptune. But as these planets cross each other every now and then, though affected by the sun, they are also affected by other planets that help pull them back in to the gravity of the sun. This is why we get these elliptical orbits. In some of my thought process, more elliptical than they need to be. There definitely can be elliptical orbits, but I think they're more elliptical than they need to be. But with the galaxy in general and the chain gravity of the stars, because of how massive they are, we get less elliptical orbits until we get really close to the black hole. So obviously all the bodies around the black hole are affecting each other in gravity, keeping them pushing forward, but not too much closer to the black hole until they finally reach their end of the event horizon. I also have an idea for the singularity as well, but it's going to sound simple, but it's not too simple. So people talk about the singularity of the black hole, understand that all the forces in the black hole, outside and in the black hole, are working together in tandem. So the singularity of a black hole, there isn't really any singularity of a black hole, because you can get as small in energetic frequency waves as you want. There isn't a smallest energetic frequency wave, because they're all in a little bit of different sizes, but they're relative to their size, they're an area. That's why we get different particles of different sizes. But the idea that the singularity of the black hole might even be the event horizon, or closer under the event horizon, not just some single point. And there's a reason why I wanted to explain that, because I wanted to get into quasars. So as we understand that light cannot escape a black hole, at least weak light. I wanted to emphasize weak light. So that's light that hasn't been condensed down. We get into the gamma ray. This is a hypothesis, by the way, and I understand all the scientists who've been working on this for years, and I could be entirely wrong on the black hole thing. Do not disregard the rest of the things I've said, because I've used experiments and I understand about the string theory and stuff like that, and I've got into the particle wave experiment as some of my evidence and entanglement that I've researched as well. So if we get to the black hole, the hypothesis for this one, and I'm going to leave this as a light hypothesis, is that the pressures of these particles inside the black hole get extremely close to each other. And we know about weak force. So they get into their weak force. All these particles and stuff get so close that they're into their weak force, and weak force starts to build up inside the black hole, effectively becoming a counter force, because as we know, weak force is stronger than gravity. And that is why the gamma ray is producing enough power to be 1/3 more powerful than the gravitational pull of the black hole in its density, allowing it to produce a gamma ray. We also get some quasars, cool stuff like that with black holes, and certainly this isn't the last thing, but that is just the beginning. This might actually involve a new science. This might involve making wormholes. People are talking about warping and stuff like that. You could do warping with with weak force, if you think about it, if you can overpower weak force and gravity. But I think it would be a lot cheaper in power to do wormhole stuff like that, which would be really cool. And warping would obviously be more advanced in the long run. But wormholes are definitely a great second, but that's way in the future. I hope you enjoyed this video. Please like and share. I hope to get this peer reviewed. Joshua Lester Blackmon. This is my theory, energetic frequency waves. It explains, I believe, from a quantum mechanic level to a relativity level.